So welcome everyone to this session on drone data management. So today we will present our first recommendation. So we are very excited to present them to you. Yes, welcome also to new members of RDA. So RDA are 6 guiding principles that are openness, community-driven, consensus, harmonization, inclusivity, and non-profit and technology neutral. So we'll try to follow this guideline as part of our session. Yes, as I said, this session is recorded and we do have collaborative notes. So if you want, you can put your name in the list of the attendees. So today we have quite a nice agenda because we will be introducing our first recommendations that we have just published online on Friday. So this is very new and our recommendations are still open for review. So we look forward to your feedback. As you might not be aware of what we have been doing in the last 1 year and a half, so we'll first introduce the working group and then we'll show you our methodology and we'll then go through the different steps of managing your drone data. But before we start, maybe we can just have a little survey. So maybe you can join us on Menti. So here are the slides. So I'm not sure if you are, so you can go to Menti or you can and enter the code that is written on the screen, or you can use a QR code. And so this was mainly to know what is your level and what do you know about drones. So in this presentation, and as it is on our recommendation, we talk drone in a more general way. So mainly our sessions, we talk about remotely piloted urban systems, so or RPAS. But it also referred to, so it can refer to fixed wing platform or a small quadrilateral type of system. So we don't discriminate the type of platform. It's something that is just flying autonomously. Yeah, so, oh, this is not this one. Oh. I think I'm missing some slide. What happened? Yeah, this was a question I wanted to show. So maybe just as an icebreaker, yeah, the question was, where are you from? So I'm joining from Cambridge in the UK, but we can look where we are from. And yes, I forgot to say I'm Alice Fremer and I'm co-chair of this working group. And we have also Jens Klam, who is joining from Australia, from CSIRO. And we have also Franz Gerard today joining as a presenter, who is from the UK and working at CEH, the Center for Ecology and Hydrology. Okay, nice. So now we wanted to know if you had already used drones, so RPAS. So if you have been involved in any, or have you been or are you familiar with mission planning or data collection or data processing pipeline, metadata and storage or data publication or reuse. So in this you can just rate what is your level of understanding of all of this? Thank you. And I see that some new people have joined us. And so if you want to join the Menti, so we are on Mentimeter at the moment to do a little survey, and we are looking at how well you know drone data. So don't hesitate to join. You can go on menti.com and use the number that is at the top. Yeah. So now, if you have any question, you can still put them either in the chat or um, on the Menti as well. We'll keep it open and then we go back to the presentation. And now I will hand over to Jens, who will introduce the working group.
Yes, thanks, Elise, for starting us into the session. And I'll give you an introduction to the working group and what we've done so far. Next slide, please. So this working group started out of a pre-existing interest group, for those familiar with how RDA works. It started in July 2024, and now we are at the end of this working group phase, and we have our outputs submitted for review. What we looked at was the fact that the remotely piloted aircraft and similar systems have become important tools for data collection, and they do this in more and higher volumes of data, and also the hardware has become more and more accessible. And then we also have more computing capabilities and infrastructures available, but not always at the right scalability. There's a mismatch between the needs of the capabilities of the drone operating groups and the compute infrastructures, and also the fragmentation of the land-based community also made progress quite difficult. So we also looked at the use of autonomous platforms in marine research, which is very well advanced and coordinated, and looked at best practices we could pick up from there, and what could be transferred to small uncrewed aircraft systems data management. Next slide, please. So what the working group did was we collected use cases on data collection and data processing from those platforms from different disciplines and documented best practices. What this was supposed to achieve was to collect material, to develop guidelines to develop recommendations for data and metadata and best practices for data coming from small uncrewed aerial vehicles, and focusing on interoperability with research infrastructures like the European Open Science Cloud and other virtual research environments. And then, so the expected outputs were specifications of those metadata, and a demonstrator to show how these guidelines support the design and implementation of cloud-based data infrastructures for drone data. Next slide. So I'll briefly explain what we did, how we got there. So we had regular meetings of the working group that was built on top of the interest group. We met monthly as a group for working meetings, and then had oral sessions at plenaries 22, 24, and 25, and also presented at EGU 20, the European Geosciences Union, um, in 2025. And actually, I don't know what NZARC is.
Yeah,
Sorry.
it's a net zero airborne capability in the UK, and it's a working group where we did present the working group, and we did that more in the UK, and yeah.
Sorry, I got completely misled, because over here in Australia, when we see NZ, it's usually New Zealand. I thought
Yes.
we didn't do anything with New Zealand. And over that time, we continued to compile use cases, but that wasn't all. So in the next slide, um, well, you can access the use cases. We've put them online using this QR code, and I'm sure there's also a link in the session notes. And the structure of this was fairly free form because of the diversity of requirements, but there was an underlying structure where we wanted to find out not only who contributed this, but also the different life cycle stages, the target communities, what the expected outcomes were, in particular, what the challenges were, and how it related to other projects. Next slide, please. And from analyzing the use cases, we identified a series of common challenges. One of them was data storage. The now high data volumes of imagery and sensor data are quite a challenge for traditional storage capacities. Then, because of the variety of disciplines, there's also a wide range of data formats that are in use, and um, this is related to the operation of the platform itself, but also um, the sensors, and especially um, in the platforms themselves, the information is often encoded in a proprietary format and cannot be easily read. What we also saw that was that it there were gaps in how data pipelines and processing could be described. So when from remote sensing practices, there were already good established practices for how to document the sensors and the sensor data and the captured data, but in the follow-on processing, there was a lack of best practices to describe complex pipelines. And again, this often involved proprietary software. This then has effects on also the metadata and the interoperability, and the inconsistent metadata and lack of standards then really are a barrier to discovery and reuse. One particular aspect we were tasked to pay attention to were the um, implications for ethics and privacy when remotely piloted aircraft capture data. They can sometimes capture data that touches on privacy concerns, even though we might initially not think of them. And there can also be ethical consequences from that. And we were specifically asked to look at those, and we'll be talking about that a little bit later. Next slide, please. So the recommendations. Where are we?
So now we have published our recommendation and they are open for review until April the 11th. So we would really appreciate your feedback because this is by having lots of feedback that we can make the recommendation better. And so the work we have produced is mainly intended to researchers, data manager, but also small and medium size enterprises operating as drone service providers. And as Jens has said, we have taken care to really take into account privacy and more legal and ethical consideration as part of the recommendation, but it's still with the point of view of a data manager. So we did include the FAIR principle and the CARE principle, and we did make sure that we have them in mind when we produce the recommendations. So the recommendation has been developed around the data life cycle. And for each step, so mission planning, data acquisition, data processing pipeline, data storage, and interoperability and data sharing and reuse, these are the 5 big steps where we will guide you through as part of this presentation and present the recommendation, but also other examples and use cases. So when we talk about mission planning, we refer to any pre-flight activity required for a successful survey. As part of data acquisition, we refer to other activities surrounding the collection of the data, and we do cover some legal ethical requirements that need to be taken into consideration when you are on the field. For the data processing pipeline, we refer to the step when you process the data, and this is include pre-processing to the production of derived data, and this include, for example, calibration and quality assessment tests. For the data storage and interoperability step, we consider the storage, but also ontologies and metadata recommendation to promote better interoperability. And for data sharing and reuse, we refer to any requirements related to the publication of the output in order to foster their reuse. So here are our recommendations that we have summarized in this type of little diagram. And for each step, and we will guide you through, we will have a recommendation section. So this section gives general principles to follow. And then, so in dark green here, you will have more the like the data management principle, but you will in light green you will have also recommendation related to more privacy, legal, and ethics recommendation. And then we will have for each step also a resource and additional information section that provide more practical and actionable recommendation for specific domains or external resources of interest. And then we propose a use case section. So as part of mission planning, the recommendation are to choose the platform and the sensors that are in line with your survey requirements. Then to plan your survey lines, taking into account the restrictions of the environment and define your standard operating procedures accordingly. To make sure you prepare all the required equipment and storage for acquisition before you are in the field, and write a data management plan that documents which data to keep for long-term storage, the data volume, file formats, and metadata requirements. And then, as part of more the privacy, legal, and ethics considerations, we recommend to define clear purposes for data collection in order to communicate more easily with your plan with local communities, to get familiar with legal requirements and civil aviation rules, and ensure any institutional procedures are there too. And then apply the care principle if working with indigenous communities. So as part of our additional resources, we give additional information to platform choices. We do have example of SOPs so that you can see what your SOP could look like. And then we give recommendation of data management plan tools. We do have a link to International Civil Aviation Organization state rules, and we have also some publication that are discussing ethical consideration and linked to the care principles, so that then you can dive into more details in these areas. And now I will let Jens speak more about ethical consideration, especially in Australia.
Well, I think it's not specifically Australia, but what most drone operators, when they think of the legal side, think of the civil aviation rules and maybe the internal company rules for operating aircraft. But field work is usually conducted on someone's land, and in most countries, this means you need to have access to this land. You have to have appropriate access arrangements with the owner, and it depending on how much time you're going to spend there, it's also good to inform the local communities about the planned work, because um, it people can see drones as intrusive, and um, there might be local circumstances that you haven't that you weren't aware of. A specific situation is when you are operating in areas that besides the uh, modern day ownership arrangements, also traditional ownership arrangements, like in Australia, where um, land rights and traditional ownership by indigenous communities intersect. And there it is important that um, you also are aware of those aspects. So, as an example, a culturally significant site might be located in the national park. So, you have permission from the National Parks Authority to operate a drone in the national park, but you should still then and you actually need to get permission, have a dialogue with the traditional owners to find out whether there are any um, sites of cultural significance that you have to be aware of. What that means is that um, you're taking pictures or measurements and exposing those to the world if you want to publish them might be in conflict with the cultural arrangements that this uh, indigenous community has about access to the sites. So um, it's a very simple black and white example. Some sites are women's sites and some sites are men's sites. And if you just put it out on the internet, people who are not supposed to see those sites might see those sites. So you have to be aware of that. So you have to consult with the owners and also ensure that the physical integrity of the sites is preserved, and the data and knowledge about the sites are shared in a culturally appropriate way. There are things that are explained in the care principles and associated works that give you more information about how this can be done. And specifically, since we're publishing recommendations in Australia, this means that traditional owners can, as a default way, be approached through the prescribed body corporate of a relevant site or native title area.
Yes, thank you, Jens. And I think this is a very important, for drone, like to really take into account all these requirements and make sure that everybody is aware and pull in the conversation really at the mission planning stage. So now we move on to the data acquisition phase. And to introduce the subject, we have Thabo Semong, who is also co-chair of the working group, has recorded a short video because he couldn't join us today. So I will just put the video and hopefully it will work.
Hi everyone, my name is Dr. Thabo Semong. I'll be giving you a presentation, actually a short presentation in terms of how we operate our drones from the Botswana International University of Science and Technology. And for this project, we were doing aerial inspection of the power line for the Botswana Power Corporation, or the BPC. We had a partnership with them in terms of assisting them to inspect their power line. And this is necessitated by the fact that these power lines are up there and they don't have something that they could easily use to look for faults within their power line. Hence, they just look using or search for faults using their stuff. So somebody will just walk under the power line and keeps on checking if there is a fault there. And by so doing, it becomes very easy to not or to fail to identify or to see the faults. And then even after they have done those inspection, they will just realize that or the power is gone or there is a power cut due to a certain fault that they did not identify. So it's actually very difficult to identify those faults within their equipment. So in this partnership, we were flying drones on top of their power lines or on top of their equipment so that we can identify the faults that may exist. As you can see here, this is a transformer that has a problem. As you can see here, where I'm pointing, there's a broken something here. I don't know what they call it, but as you can see there, there's a problem, which means sometimes when they move around and inspect this using just their eyes, meanwhile this thing is up on top of their heads, it's not easy to see this kind of fault. So the drone was very helpful in terms of identifying the faults because the drone flies on top of the power line and it becomes easy to zoom and identify these faults. As you can see here, this is a problem of a fuse. As you can see, it is broken here. It's supposed to be like these ones. And with the drone, it becomes easy now to zoom in and identify this problem, which if it's a human being just walking around checking, it's not easy to identify. As you can see here also, we have this insulator here is bent. This is a problem of a bent insulator. So the drone was able to identify it. And what is interesting about this one is on top of the insulator, which means if you are walking under this power line, you won't be able to see this. But sometimes because of this, there's a problem of electricity. And this one is a simple one. As you can see, the power line is going through the trees, which means these trees have grown up and they need to be cut. And sometimes it takes a while. When it becomes rainy or windy, then these trees, they somehow cut or break the power line and it becomes an issue for them. And another example here is the broken insulator. And this insulator, as you can see, is broken on top. when you are moving underneath this power line and you just look up to see if everything is fine here, you might think everything is fine and you pass, but this insulator is really broken on top here, so it becomes a problem. Another example of an insulator that is broken. And here is another fuse that is broken there. And it's just some of the examples that we managed to pick, but there are so many of them that we could present or that we could share in terms of what we find out. As you can see here is a typical problem. And for this one in particular, they had a problem because there was a power cut and they didn't know what is the issue until we came and flew our drone on top of this pole, and we managed to see that indeed this insulator has a big problem because the power could not go through this insulator. Hence, it had to be removed. And there were so many examples of faults that we did manage to pick through the drones. And one of the things that we were also helping them with is to identify where these assets are in terms of the getting the coordinates so that we can plot them on the GIS. Then it becomes very easy to have the map of their power line. And as you can see, this transformer is leaking. There's a lot of oil leaking out of this what we call the transformer. And the good thing is that immediately after we have managed to inspect the power line, we give them the reports, we give them the data that they need. What they give us really is the asset to go and inspect. And when we reach a transformer, they want us to check 1, 2, 3. And then when we reach a certain asset, they want us to check 1, 2, 3, like the poles. Mostly we need to check the insulator if there is any wire breakdown or if the insulator is intact. So they were able to go and fix all these problems that we have identified, and this really made their problem in terms of power cuts to go down, and they were very happy. It was a pilot project that we were doing around the outskirts of the city, but it's a project that they want to roll out throughout the country because they believe early identification of these faults and attending to them will really help them to be proactive instead of waiting for the problem to arise, then they go and fix, because that kind of reaction is not good, as it will leave so many communities without power. So it's an initiation that they really appreciated, as it helps them to fix the problems before they happen. As you can see here, this is a typical example of what they were doing. Once we give them the report, they go to the line that we're working on and attend to all the faults that we found. And from the report that they gave us, this have really helped them in terms of ensuring that we have continuous power supply. I think I'll have to stop here for this presentation. I hope I have shared something important. Thank you very much.
Yeah, so this example was really to showcase that as part of our working group, we have been working with use cases that were really from different countries, but are from also different discipline. And so that was to introduce the data acquisition side. And so now we'll look at the recommendation for data acquisition. So in terms of data and metadata, we recommend to use the data collection checklist to record all the required information for future processing. And I will go into more details about the data acquisition checklist next. And calibrate your instrument following best practices. In terms of privacy, legal, and ethics consideration, you need to adhere to relevant national civil aviation rules, institutional procedures, and access restrictions to undertake safe operations. Build trust with local communities through consistent ethical behavior and follow best practices regarding environmental and wildlife protection. And so, as part of the resources that we provide as part of this data acquisition step are the log sheet for easy data acquisition, calibration, best practices documentation, and work recommendations on flying drone around wildlife. So here are the log sheets. So in the document, you have access also to Zenodo, where we have also published the documents as and you can modify them for your own needs. But the data collection checklist is a way for you to go on the field to have these sheets and to just tick as part of your survey that you have everything as you had planned for. So you have like all your summary data collection documents. So this is for going on on the field, and then you have all the information regarding each flight. So and this will be then like filled into a survey log sheet where you will log the flight ID, the site, the pilot, the observer, when you started, when you ended, the location of where you started your survey and where you ended it, and then some environmental information such as the wind speed and direction, if it was raining, if there is a cloud cover, and visibility information. And then you can also have information regarding make sure that you have all your instruments on while you fly, and you can also tick which sensor was on, as sometimes on a drone you might have different sensors that you have on or off depending on the flight. And then you can list all the issues and have a time, an event log with each time. Yeah, you can record the time and an event as part of this log sheet. And now we have another presentation from Sarah, who will give you some insight on how she has been using the information and the recommendation of the group.
Hi everyone. Thanks so much for having me. My name is Sarah Manthorpe. I am here on behalf of University College Cork and MARI, which is a Marine Institute, Marine Research Centre in Ireland. I'm based in Cork. I'm a PhD student, and a lot of my research focuses on wildlife surveying in Ireland. So I'm here to talk to you a bit about the importance of data acquisition and logging specifically in the field using data log sheets. So I use data log sheets all the time. Wildlife monitoring can be a bit spur of the moment, a bit stressful when you get a weather window or when you get an opportunity, you have to take it. And so it's extremely critical to be able to record all of the environmental metadata that you have around you in that moment with you and the observer if you were the pilot. So that might pertain to the environmental weather conditions, whether or not you're having clear skies, cloudy skies, what the wave height was looking like if you're on a beach or if you're deploying from a boat. Did you have sort of rocky cliffs like in the left-hand image, or were you looking at beaches? All of these things might impact your ability to retrieve information from the imagery later on. Secondly, you're looking at sort of the survey conditions. What kind of winds were you dealing with? Did you have to deploy from a boat, or were you deploying from the same place on land? Did you have manual flights, or were you able to pre-program a route that you can export and then follow at a later date? Did you follow appropriate legislation that pertains to the region that you're working in, whether or not that's having signage around where you work, complying with aircraft regulation on specific heights that you're allowed to fly at? All of these things need to be noted down, especially when you're flying quite frequently, because you might not remember which piece of information goes with which flight that you had conducted. Importantly, especially in the case of wildlife, is if you noticed any disturbance, whether that be with seabirds or seals, both of which are quite vulnerable, having the observer keeping an eye, recording information, potentially stopping flights, or flying at a higher altitude, all of that needs to be recorded and potentially fed back to, in our case, it would be the National Parks Department, but it depends again on what you're doing exactly. And all of this information just feeds into what you're able to do with the data and maybe what you needed out of the data in the first place. So, for example, in the left-hand corner, we're doing a gannet survey off of the southwest coast of Ireland. And here it was important that we make sure we noted the surveying conditions because they were supposed to match a previously done helicopter survey from a few years prior, where the imagery is oblique. It's stitched, but not using photogrammetric tools. It's just using different kinds of software. So you need to make sure that you try and get images like for like so that the person who ends up manually counting them is able to do so and that they can build on this long-term data set in the same way. Versus the photo in the middle or the top right-hand corner is where we're doing seal surveys, and in that instance, it matters much more that the drone is facing fully down and that you've recorded that information, that you're stitching at 70 or 80% overlap using different kinds of software such as Pix4D or Drone2Map so that you can potentially look at things like 3D tools, things like body condition of seals hinge on you having collected the data in a very specific format. Lastly, we've got the photo in the bottom right-hand corner, which is thermal detection of puffins. So this is a newer project where we're looking at puffins when they're burrowing, when they're nesting, and they're quite difficult to detect. So this is again actually a manual flight. You wouldn't necessarily pre-program this at the start. This is sort of exploratory work where, again, it's also sort of like for like, trying to make sure that the calibration of the drone for the thermal imagery matches the visual so that we can say, okay, well, I can detect a puffin here and I can detect a puffin here, and we know from other ground truthing methods that that is an occupied burrow. And because that's new work, we're sort of in a more exploratory phase, so you really want to record all of the survey conditions that you had in order to be able to replicate successful detections again. And all of these things help you later down the line when you're processing or when you're annotating data. An example is when I have done work in the past on albatrosses, we had issues with the drone collecting sort of spurious elevation values that we then ended up pulling the flight logs and pulling the logs we had collected information of to get elevation values from the drone directly, and that was really only possible because we had collected all of that information and it enabled us to do the processing we needed to for that project. So it's just super, super critical. And when you're doing loads of surveys back to back, you might not be able to associate metadata from one survey to another. So it's just key to use log sheets like what was in the previous slide as much as possible, making sure you note down all of the information that you think you'll remember because you just never know. Well, and that's all from me. So thank you very much and enjoy our DA.
So this is the end of our first part, and now we have a short time for more discussion around this theme. So if you want, we can go back to Menzi, and I will try to go out of the... And so I think this is, yeah. So, oh, okay. I think we wanted to have a bit of feedback on what you thought about the first guidelines regarding mission planning and data acquisition, and if you have any feedback for us on these two themes. So now we have a survey on how would you rate the recommendation and our additional resources. I appreciate that we haven't presented everything that we have in our recommendation, but if you think that there is anything lacking, please let us know. So I don't know if you can respond or not. I'm not really sure. I can see that 6 people are active, but I don't know if people can vote or not. Thank you. That seemed very good. Yeah, so to join the Menti, you will need to go to menti.com and use this code that is, I can copy the code if you want and put it in the chat if you are able to. I'm not sure. Yeah. Okay. We'll move on to, do you have any feedback for us in terms of data acquisition or mission planning, and if you think anything is missing? Otherwise, I will give you a minute. You can put your question either on Menti or in the chat. And if there is no question, then we can go back to the presentation. And now we will have friends who will discuss the data processing pipeline. But if you have any questions, don't hesitate to put them in the chat, and we will have a discussion section as well at the end.
Yes, hello. The data processing pipeline, of course, you've already seen 2 use cases, depending on the type of data you're collecting, the pipeline will probably look quite different. But it's always really important that you document the processing workflow following the data processing checklist that we've produced. You separate between the raw, pre-processed and processed data, and you use version control. Also, think about providing information about quality statement, how you've actually carried out your quality assurance, and the control that you apply to your data, how you calibrate it, and also how you processed and then validated the processed data. Also very important that we think about the privacy legal and ethic considerations. So if you have people on your imagery, blur or anonymize the personal data. And so, for example, if you want to protect certain sensitive locations, reduce the precision of the data. So people cannot actually find where you flew your campaign. Next slide, please. We have provided additional resources, and here are the links that give you additional information about pipeline processing and metadata. So there's a description of processing level, data standards. We also have a list of processing metadata, so common discovery metadata schemes, RPAS metadata from a paper that we've found, also domain-specific metadata, for example, atmospheric sciences. There's also a link to the European Aviation Safety Agency Privacy Handbook, and then best practices for generalizing sensitive species occurrence data from GBIF. Next slide, please. Now, when you think about the data processing pipeline, your metadata, there's different levels of processing that you go through depending on what you're planning to do. Some individuals will collect the data and then pass it on. So we're talking about raw data. Other teams will pre-process the data and then pass it on to their colleagues. And then other teams will go through the whole processing pipeline where you're collecting the raw data, you pre-process the data, and then you derive also information from it. And generally, in the remote sensing teams, we tend to talk about level 0, level 1, and level 2. And when you think about level 0, that refers to raw data. In there, you identify everything to do with the mission. You specify your sensor, the platform that you used, and the flight parameters. Also specific details regarding potential issues recorded in the field. So that's the data log that the previous presentation mentioned, and the type of data, output format, and description of the variables. When you talk about level 1, that is anything to, so this is all the pre-processing, prepping the data. So I would think about it as analysis-ready data. You prep it so that at the end, you'll have data sets that people can use for analysis and then deliver derived products, which is level 2. So there you provide the level 0 data information. You identify the parameters that are related to the calibration that you carried out, the methodology that you applied for the pre-processing, for prepping your data, the quality assurance, quality control flags, or methodology, your georeferencing methods, corrections applied, and the software that you use in version, also the type of data, output format, and description of your variables. Level 2, that could look like a wide variety of things. It really depends on what you're deriving. But don't forget to mention level 0 and level 1 data information, the methodology you used, the algorithms you used, the models you've used to derive your data, versions, software versions, model versions, anything you can think about actually that will help somebody reproduce this derived data. Reference data as well that you used for training and validating, and the spatial resolution and the coordinate reference systems that you've used. And again, type of data, output format, and description of derived variables. Next slide, please. Now, I've been talking about 1, 2, 3, 0, well, 0, 1, 2 levels. However, there's a really good reason why we should move away from sticking with numbers. So, for example, here we looked at the NASA Planetary Data System data processing levels, and they've moved on. So they've had different versions, and they've moved on from version 3 to version 4. And changing from a numbering system to actually a term system. And the reason why is because there's been quite a lot of confusion when people then look at the different levels, and different teams would refer to level 1 to represent different types of level of data. So here, this is an example of data that I use quite often, which is RGB imagery collected. And what we often do is, from the raw data, we would pre-process to create mosaic data sets, which are co-registered, and we end up with a 2D image mosaic. And then there would be a classification of the imagery, and that would be the derived data set, which would be a map. So when you stick to the numbering system, you would have level 0 for the raw data that you've collected. Then the pre-processing, which is the mosaicing, would give you a level 1, which is the image mosaic, and you could refer to it as partially processed. And then the map would be level 2. Now, but imagine that we're actually interested in reflectance, some form of calibration of these images, so we can actually do time series analysis, and we can compare one image from one time point to the other by either normalizing or creating reflectance data. And then all of a sudden, level 1 becomes a little bit more tricky, because we have 2 bits of processing that are actually quite important. First, we will calibrate the images, the individual images, and then we will mosaic them to create a 2D image mosaic of reflectance data. And so either you would have to refer to level 1A, level 1B, and then it gets a little bit confusing. But by using a term, it becomes very much clear in terms of what you've done. If you go to the next slide, I have an example for LiDAR. So here's an example for LiDAR, where on the left-hand side, there are different processing levels referring to the intensity values that you collect, because when you're collecting LiDAR, there's 2 things you're collecting. You're collecting information related to the height of the features, but also information that is the radiance, so the intensity of the values that you're collecting. And the intensity values, you can actually transform that into, calibrate that into reflectance value. But as you can see here, this is from a document, this is aircraft LiDAR, but it applies to drone LiDAR as well. You can actually have different levels within this pre-processing calibration part of the pipeline. You can start off with the georeference data and then do a pseudo correction, an intensity correction that's more of a dealing with the range incidence angle, but it's not actually reflectance. And you could call it level 1B, but actually when you say pseudo reflectance, it's much more clear what you've got there. And then you can, the next level is you normalize the intensity. So there we're talking about, could be level 1C, but it makes more sense if you called it normalized pseudo reflectance. And then at the end of the day, if you've reached the stage of calibrated reflectance, then you refer to calibrated reflectance, or you can call it level 1D. But if you stick with the numbers and you've also done something with the height information at the same time, and that's on the right-hand side, this is a processing pipeline that only deals with height, where you first georeference, then you normalize the height, and then you derive information from the height. Again, the level 1 area is you will have to split it up, and if you don't use a term, level 1A could be either a georeference. Well, georeference is level 1A, but level 1B could either be normalized height, or it could potentially be pseudo reflectance or normalized pseudo reflectance, etc. So that's my use case examples here. And next slide. So before we move on to the data and metadata, which my other team members will continue on, is just to clarify that our recommendation would be don't use numbers, use terms. And within your community that use a particular type of data set, either LiDAR or RGB or thermal, maybe come to an agreement in what the terms are mean, or add a definition about this term actually means this. And that's me for today.
And Jens will speak about data storage and preservation.
And thanks, Francis. Those were really good examples to illustrate why we should explicitly name the processing levels, and numbering is very context dependent. So speaking about our recommendations for data storage and preservation, they don't deviate much from what is nowadays considered best practice. And this is why we recommend to use the recognized metadata standards that are already used in your discipline. And if there are specific recommendations for drone data and metadata, follow those as well. Use open formats where they are available, which is also, I think, very much in line with best practices in research and open science in general. What we also recommend is to adopt ontologies that are used in your area of research to enhance the semantic clarity and interoperability of the metadata. Because often we talk about the metadata elements, but we increasingly also need to talk about how we use those elements, how we fill those fields. And then often the drones that we use are instrument platforms. They're not an instrument in themselves. And we recommend to use persistent identifiers for instruments, following the recommendations from the PIT-INST group in RDA to reference the instruments, the sensors that were part of the platform, and make it easier to trace what was used. And on the side of privacy, legal and ethic considerations, there might be specific requirements for access restrictions, and those need to be taken into account. So we've summarized that also with and given a series of links to give additional information about metadata, schemas that are already available, the list of recommended formats, some recommended ontologies, and a pointer to the PID-inst work, the persistent identifiers for instruments.
Yes, and now I will dive a bit more into details about the metadata, and this is what we meant by giving the right metadata to describe the drone. And so it works by pillar, and so you have a different type of metadata that we recommend. So you have first discovery metadata, and this refers to the metadata that enables the users to find and identify a dataset. So this is like common metadata such as the title, the name of authors, the date of creation and publication, an abstract and an identifier. And these are really minimal metadata, but more for discovery. And then we can move on to more the drone-specific metadata. And as part of the drone metadata, so this work has been based on the work that had already been undertaken by the interest group. And so the references that are given here is a minimum information system for drone metadata that is from this publication. And the drone metadata have two kind of types. So you have the common drone metadata that are like information about the platform, such as the payload or the stability, and then other information regarding the sensors, the calibrations parameters, the project, so that the community can assess the quality and understand the potential bias of the data. And then there are specific type of metadata depending on which type of data you collect. So either you have image metadata, so that, or you have sensor metadata. So this really depends on what type of sensor you have on your drone. And then you will have domain-specific metadata. So this is more developed to respond to the needs, terminology, and data types of a particular academic discipline. So, for example, if you are working in the earth and environmental sciences, the common standard is the ISO 19115 standard, and for atmospheric science, you can also use CF convention, so this is really to showcase and really say like there are different levels of metadata that you will need to provide. And as part of the guideline, if you follow correctly the collection checklist, all the metadata we are describing here, you should have already collected most of the time from the collection level, the collection stage, but also, as we have seen with friends, with the processing log sheets, then you will have all the metadata related to the processing workflow. And then we have also contributed with the list of different formats. So I won't go into all the details, but we did have different type of formats we recommend, because there is a difference between the format for for distribution and also for long-term preservation. And so there are formats that are really good for sharing a huge volume of data, while some formats are better for long-term preservation. And now I will share, hand the floor to Jens, who will speak about the data sharing and reuse.
Yeah, so when it comes to data sharing and reuse, we stay very much with what's already established as open science, as an open enterprise. And so we recommend that you share data through a trusted data repository using open formats. And with all the necessary metadata required for reuse, so aligned with the FAIR principles. But also following the idea of open science, this means as open as possible and as closed as necessary. And sometimes there are reasons why things cannot be made fully accessible. So there we recommend to adhere to the privacy laws and ethical guidelines, particularly when it's about sensitive data. And as I said, as open as possible, as close as necessary. And the license you choose should reflect that. It should support the openness where appropriate, but also guard other aspects if necessary. So in our recommendations, we point to the Registry of Research Data Repositories, RE3Data. We point to the definition of open science, and we also point to licensing resources to help choose appropriate licenses.
Now we arrive to the final use case, and so this is a use case from the UK Polar Data Center. So at the UK Polar Data Center, we publish a lot of data sets that are from many disciplines, but the data have been collected in polar regions. And here we have two very different experiences in publishing data derived from drones. So the first example are gravity data that have been collected in Western Antarctica with using a fixed-wing drone. As you can see on the image, so this is a very large drone, but the sensors were really similar to the ones they used on aircraft. And so here we were able to really follow the pipelines and the workflows that we usually use for publishing the data derived from the aircraft. And so we could basically publish the data and using our Polar Airborne Physics data portal. And so where we followed exactly what we used to do from aircraft. And the scientists were really used to using collection checklist, and they had already all their procedure in place. While in the second example, it was data collected for sale colony survey data that have been collected in South Georgia. This time it was scientists who used also a very smaller fixed-wing drone, as you can see on the image, and they were taking images of sails. But this time we have much more trouble to publish the data because our data, some of the log files were in proprietary format, and we were not able to find a solution to export those into open format without losing some key information so that it could be reused. So for the first time, we had to publish the raw data as it is, but also a version, but that was a bit less informative, that was still in open format, but we did publish the two together. And then the data were processed, and we did have to describe the different levels so that the data could be reused. And this is where the work of friends will be very helpful in the future, because I think we still use the level 0, 1, 2, but I think using in the future the name of the level would make the data a bit more easy to be used in the future, but so that we will change a bit the metadata so that we include also like the different definition, so that people can understand what step has been definitely undertaken at each stage. Yeah, I think this is all for us. And so now we have approximately 15 minutes for discussions and questions. So what I propose is that we go back to Menti, and I will this time really put the link in the chat. And okay. Okay. So yeah, the questions is regarding the second part of our presentation, where we just discussed the recommendations regarding the processing pipeline, the data storage and interoperability stages, and also the data sharing and reuse. So yeah, to have like, I understand again that we haven't presented everything that we have in our recommendation, but it's to have a first feeling if we are missing some big things, and if there are gaps we should fill as part of the review process.
And there seems to be a problem with the Menti, because I did always get a different page than you see. Currently, I get how would you rate the recommendations page, so the one you had previously. And when I was there on that page previously, I got the also I got something else.
Okay.
Okay, yeah, that's the one. That's the one I have now. Right.
Okay. And I see that Leslie has just shared like a publication, and this has been just published and it has been raised to our attention. So this is the paper is from Florian Elsesser. I'm sorry if I said it wrong, et al. And it's towards a fair metadata framework from drone and uncrewed aircraft AI cost data, and it has been published in Scientific Data. In fact, it has just been published, and this is definitely something that we will be adding as part of our recommendation, as part of the additional resources for when we do the review process, because yeah, we were not aware of it when we wrote the recommendation.
Yeah, just a comment. It does do what is it's still using the level 1, 2, 3, 4. But it's just interesting because
So,
for the
do you have any
metadata,
question or feedback you would like to share with us?
or can you hear me?
Yes,
I
I
can
hear
hear
you.
you, yes.
Oh, I was just going to say, no, it's interesting. I'm really interested in what you said about the 1, 2, 3, 4, levels, and how it's possibly time to move on from that. So there's two things with that paper. It does use 1, 2, 3, 4 in recommendations. The other thing that's interesting about it is for the metadata, it gets into all sorts of variants of the ISO 19115 metadata standard that I didn't know existed. Anyway, it's just a comment. I was just wondering, I didn't know whether you considered it, because I agree it only came out in January, I think so.
Was Leslie speaking? Because I don't have any sound at the moment. So
Ooh.
I think I would just.
Leslie, that's really interesting, and I will definitely dive into that paper and have a look and see how we can refer to it rather than just mentioning it as a link. Maybe refer to it a little bit more in depth in our recommendations.
Yeah. So maybe I can also
If you
comment on that.
can,
Yeah. Sorry,
if you
Leslie.
can
Go on.
hear me, oh, sorry, I was going to say, if you can hear me, it actually does go into detail on the ISO 19115 suite of metadata standards, and it's kind of worth looking at, because it was another variant. Still, I can't see anything that's in that paper that's at variance with what you're saying. It's just got some interesting details. Sorry, Emmanuel, over to you.
No. I was just going on a different topic, so I'll just finish that if you. So the thing I was going to ask about was also maybe derived from our experience from the data help desk last year. Remember when there were so many people coming and asking us for repositories for particular data, in particular remote sensing data. So I don't know if that's even possible, but I was just searching V3 data for drone data, and there's only one result if you search for drone. And that is not even exactly relevant for, I mean, it's relevant for drones, but it's not something where you can deposit or actually get data. That's the dead trees repository. I think it would help people to also get into that topic if you had some recommendations about drone data repositories. I don't even know if there is a drone community where these things can be aggregated somehow, but like having something like that is, I'm just guessing there, that is in parallel to the remote sensing community, which is probably differently organized. I think that would help people to also adopt these practices and get in contact with them, and then basically adopt the recommendations, which I like very much, as a standard. But currently, my feeling is that people are less organized, and then it's more difficult to approach them.
I was just going to say one of my experiences. I've only just started helping out with drone data in the last 6 months or so. It's the sheer volume, particularly with the new high resolution machines, and so you're not going to kind of stick the lower levels of processing on Zenodo or Dryad or Figshare. And so then it becomes a matter of, where is there a repository that can take the large volumes? And that's where it starts to get very selective. Jens will probably disagree with me, but anyway.
No, I do agree with you. And I think that what we see now is the community in some parts reaching a breaking point because of those requirements. In the past, the volumes were not that unsurmountable. There were commercial platforms that they could easily use, and everything was relatively accessible. A lot of scientific drone work is done with relatively inexpensive platforms compared to aircraft or marine craft. And so what we see again is this pattern of if there's no need for collaboration, people just won't collaborate. It's only when they hit a wall, when there's no progress without collaboration, then they will start to collaborate. And I think we're now approaching this inflection point in the drone community where you can't do everything with a DJI drone, Pix4D, and the propeller platform or something like that. So this will be interesting to see, and we need to find a way to also pick up where the community is moving, and maybe also find the points where we can give input.
Yeah, I'll just add, I work part-time with the National Supercomputer Centre at NCI, and the drone people are knocking on our doors now, and it's purely because of the volumes. And it's kind of interesting watching some of them adjust to the fact that it's not like they're putting the data on Amazon where they can control a lot of things. It's then having to put your data in this publicly funded repository and, oh, heaven forbid, follow agreed metadata standards and things like that. So again, that was kind of why I'm here, to actually see what standards you're recommending, because I can pass it back to the repository.
Yeah, but let's take advantage of the help desk, yeah, and to test what people are thinking and how interested they are. I mean, we could just put it up there, as we talked about yesterday, and start distributing those and see what kind of feedback we get from the community. I think that's a good chance next month or the other month. In particular, because we had so many remote sensing. I remember last year there were so many people coming asking about remote sensing data, and we didn't have anything up there. So now if we say, okay, we are answering questions about drone or UAV data, that they will probably show up.
And I think what is difficult, at least as a data repository, is that, for example, I'm working at the UK Polar Data Center, and we will accept anything from the UK Polar community, but then we arrive with very different type of data, and this is what has been a huge challenge. And so that's why we are working with the other data center from NERC, but they do have the same challenges. And so this is a big change, because now we have biologists who usually have just a very small data set with just an Excel spreadsheet, now arrive with like 1 terabyte of data, and these people have not been trained on handling this huge volume, and the processes were not as like standardized in their workflow before. So there is also a lot of training, I think, in this in this theme around drone that I think is necessary, because I've seen really a complete different approach to how you will fly a drone from the different disciplines because of their background. So the geophysicists, they did used to have lots of high volume of data, so they were more like they knew that it would be a challenge right from the beginning, while some other disciplines are less trained in having that volume, and so this is also a challenge.
Can I add to this? It's reminiscent from when I started as a young remote sensor about 30 years ago. At our institute, we realized in those days, because you didn't have cloud where the data was stored, all the raw data that we would buy or collect, we would put on tapes and then on disks, and then we had a file save, which started like a tiny little file save where we stored all the raw data. And then the file save had to become bigger and bigger, and then we realized we actually couldn't find our tapes anymore because we didn't have a database of the tapes. So we build up our own metadata or records, and basically it was exponential. The amount of data that we were storing and keeping track of was exponential, and that's what we're facing. And then eventually this file save was not required anymore because everything became available online. We didn't have to worry about keeping all this raw data to ourselves. And that's what we're going to face with the drone data as well. And I'm also being from the UK and the NERC community, the NERC community, having just worked on a European project and having collected lots of drone remote sensing data, we found out that the repository, which is not suitable for drone data anyway, is not going to take the data because it's not a UK funded project, it's a European funded project. So we are looking at Zenodo, which is not ideal. So yeah, it's a challenge, and the infrastructures, the suitable infrastructures are probably not there yet. And how can we make sure they start to appear? That's an interesting question too.
I have another question, maybe kind of different. So did you think about applying these principles to like unattended floating vehicles, because they share a lot of the same principles. I mean, they may have different data pipelines, and the different sensors on board, but in general, I think they share a lot of the same problems.
Yeah, we were hoping to have the transfer the other way around, to learn from them, coming from a more structured, more cooperative community.
Yeah, I think the difference is that the available floating vehicles are quite expensive, so they're usually operated by institutions, while the drones are available to basically everyone. So the community is much bigger and much less organized, I guess. So because the floating ones are mainly industry supplied vehicles. I don't know of many who are building their own. There's a few, but not that many. But yeah,
The whole community around certain floats. So you have all the Argo floats, the community, and everybody all around the world will do exactly the same thing and deploy them, and then it's left there. And this is like part of a whole community that has decided on how to do it right from the beginning, which was very smart. While I think the drone community is much more scattered, and the disciplines are much more wider, because mainly the AUV are used in marine or sciences. And so you have kind of a community that was already set up. And they met mainly on ships, and they know each other, and it's easier this way. But this time we have many communities dealing with the same issues, but on different ways. And yeah.
There's a community monitoring lakes, for example, with like smaller vehicles that are not AOVs or gliders or anything like that, which may be relevant for that.
And I see that we are on at 8:30, and I think this is the time of our session. But I think the discussion really showcased that it was relevant. And I would like to thank everybody who has been attending this session. And we look forward for your feedback. So to give feedback, you just need to follow the link. So I will put it in the chat, but basically this is where the recommendations are, and you can put a comment, and this is where you can download the recommendation. So yes.
So as
Thank
for the
you.
future of the group, the working group phase is now ending, but the interest group will continue to operate. So we're looking forward to welcoming new members to the interest group.
Cool, great. Thank you very much for setting this up. This was it's really, really nice results, I think.
Thank you.
Thank you.
Thank you.
Bye bye, folks. See you around.
Thank you.
Bye.